video, we move to the fourth part of the chapter 3, describing data with statistics. This part is we will follow the previous one. We understand the mean, we understand the median, understand the mode. So these three concepts are more talking about how this averages looks like. And for this chapter, we talk about dispersion. Dispersion is talk about how the distribution of the list of the number is looks like. Within this dispersion, we first understand how to find the range. Starting from range, we will define the formula for the this variation, and through the variation, we define the formula for the standard deviation. Actually, standard deviation just the square root of variation. So this this pink one or purple one compared to red one is the purple one. You can feel is if F0 is the mean, then that is more closer to the mean, and the red one is those distribution is more far away than this the purple one. The more as it's more and more closer, the standard deviations called SD is getting smaller. If SD is getting larger, then it's distribute more than this lower the SD. So from our mind map, actually I put some the concept here. So if you have a free plan, you can read is what's the range for our from the range is for our list of number. The range is the difference between the highest number and the lowest number. Then from the coding is we will first make our program to calculate range, and then from you could have two group of numbers with the exact same means, but with vast difference range. So when we're talking about range, is can have the linkage with the mean. So we will link these two. So that is the tricky part is if you got the same mean for two set of the numbers, when you calculate the range, it can be very big difference. So they are look at the data set from the different angle. So that is the range, and then the variation. So the variation is the average of the squares of those differences. So from the differences concept coming from range, and of each of the number from mean. So a high variance means the value are far from the mean. A low variance means it's closer or clustered to the mean. So that is the variation. And the standard deviation from the value part is very easy. So standard deviation is just the square root of the variation. So from here you can calculate the variation. So we can link these two. So that is if you know variance, then just make our square root operation. You can get the standard deviation. And for the value that are within one standard deviation was less or equal 1 of the mean can be thought as are fairly typical those standard deviation. And if they are more than 3 or more away from the mean, can be considered much more atypical. So we call those value are outliers. So what means this outlier? We have used that here. So when we come to this mean, you see when we're talking about it's bad to use mean to describe center of the data set when the distribution is most symmetrical and no outlier. So if you find this standard deviation is more than 3, that means we have the outliers in our data set. Then it's not good to use mean to describe the average. And similarly, is when we're talking about median, it's best to use median when the distribution is either good or there are outliers present. So that is, I make another connect. So we can calculate quantify the outliers. Then we can decide now it's using median. Is a better way to describe. So that is the concept from the this number 4 sub chapter. And let's now go to the coding. So from here is first let's make our the program to find the range. So let's make a new. So 03041 finding range .py. So we have our header. So let's change this to the find the range of a list of number. So you now know is we should have a definition of the function. Then we have our main program part. So let's do that. Is find range. Where input one list of the numbers. So range is just we need to find what's the lowest number and what's the highest number. Then find this difference between these two numbers. Then that's called the range. So then just calculate these two. So lowest number, we just use our the function is called the mean. So mean applied to a list just give you the lowest. And the highest is use max. So then find the range. So range, let's go to give this range is the highest minus lowest. Normally, it's the highest is more than lowest, but if they are same, then range is 0. So return all of them. So lowest, highest, and range. So that is when you have the return and you press enter, is back this indent. So that is the smart from Python. So if name equal to min, then what we will do is first let's have our the list. So we still use this donation, but that name can be the old any name. So okay, we have those numbers. And then we will put is if we return multiple ones, we just assign the multiple one, and they are matching the one by one. So lowest, highest, and the range. So you use the dot, the comma to separate them. So find the range. So with the donation. And then we can now print lowest is 0, highest we give 1, and range we give 2. And we have a format with lowest, highest, range. So it's very simple. So we have our data sets, and let's calculate. So lowest is 60. You can also read this from the data. So on this list, the 60 is the lowest, highest is this one, and the range is this minus 60, so it's a 1140. So that is based on the very direct calculation formula. So that is the range, and we will use this range as the tiny parts when we go into this variation. So variance. Variance, they have this the very clear formula. So for every the x number, so xi, first we calculate the mean and we find the difference of this mean, and no matter is higher or lower, because we will have a square, then this the result of this square will be our positive number, and then divided by we sum all the this difference with a square, and then divided by the number of those numbers. So that is the sequence. Then we result is a variance. Then we apply our square root, will be the standard deviation. So we will put that into this same one. So let's make our new, and we will also have this one. So let's try to change this. So find variance and SD. So standard deviation, normally we call that is SD. So let's say change this. Find the variance and standard deviation SD. So the donation list is still there, and we don't have this range needed. So we will delete that. Then we will create another function. It's first we need to calculate mean. So that will be used since we need our calculate the mean for the variance calculation. So S is the summary. So sum numbers, and N, I keep using the small case. So len numbers, and then the mean is S divided by N, and return mean. So when we call this function, then it will come to the mean, and we drop our the list there. So let's see bigger. So then we have this find differences for every numbers. And then we will call mean. So find the mean. So mean is calculate mean numbers. Then now we get a mean, and we will have this mean through the this for loop to find the difference for every this number, and we put the difference also as our list, because then we can transfer that to the next the calculate variance function. So that also read our list. So now is we see the find the difference is diff. We call that as our empty. Then we gradually push or we use this append to put the number inside diff. So for number in short is in numbers. Then diff append. What's that is this number minus mean. So that is our diff, and then we got after this we got our the diff return. Okay, so let's start to see here is calculate mean with donation, and we put here print mean. So we go to 47775. So then can put that. Then is after we have this is find difference. Also we give this and the donations. So we don't need these parts. Then let's from here. So we will print if can see here. So first number is 100. Let's also have this one. Then we have this. So we have let's make this back. Then you have those steps. So our this also because this code that, then we don't need to code this. So then just code one time is 47775 with the 100. So difference is minus 100. Let's say this 900 minus this is 422. So similar for others. 1000 divided minus this average is more than 500. So every number we calculate the difference. So then we can start to use this difference for variance. So let's define our third one. So def calculate variance numbers. So that is a different number. Is we transfer those from the div. So we don't need this one anymore. And this number is first we find the list of difference. So div is equal to find difference with this number. And then then we find this the squared difference. So we also use our the empty list and then do the for loop. So div we see is squared div first equal to empty, then for d in div we will have squared div append is the d2. So we make the squared. Then we see here we have our returned. So when we call this, we will have this to the print, and after this we will print squared div. Then you have this step, and then we have this sum. So sum is the we put all those the div. So sum squared div. Just use this sum function. So squared div, and we get another print sum squared div. And the next is we can use that to have the variant. Variant you just use this len. So variance is equal to sum squared div divided by len the number. And we will return the variance, and we print variance in main program. So return variance. And from here is we starting to call variance equal to calculate variance donation. So now we have this is our mean, this is our div, this is the squared div, and this is the summary of the squared div. And now we have the variance returned, and we can start to print the variance of the list of numbers is. We use 0, then format is the variance. So return this print summary of squared difference is 0 and 2f. I don't want that too big, so dot format and with this one. And print this, well, we don't have that, no need to change that. So now we have this variance. So let's see, so we have this is the squared, and this is the summary, and this is the variance. Let's also put this to f, so it's make that is more readable. Then the last step is we can directly use variance to calculate the standard deviation. So standard deviation is equal to variance squared 0.5. So then print the standard deviation of the list of numbers. Oh, I forgot the quote. Single quote or double quote is fine. So is 0 dot 2f. So still use that. Format and std. Now we have done all the things. Now we see our standard deviation is 375. Oh, it's too huge, the deviation. So that is the, let's do another donation. Change something in, let's, for example, let's delete those too much smaller one, and delete those biggest one. So let's see. So we only have maybe, yeah. Let's see. We have just 4. So let's see how smaller of this standard. Now it's decreased hugely to 42 because their mean is very close to the each number. So the squared difference is not huge. But if you consider here, the squared, the difference is more than 100, nearly 200 or 200,000. But here it's just some 100 and some is 1,000. So the square summary of those here is 1.6 or 1.7 million. And this one is only 7,000. And when we do the square root, so variance is just divided by n. So it's the same ratio, but the square root is very slow, very lower. So that is the ways we can calculate how this the larger or lower this distribution. So we will later to understand is how we can draw those kind of the dotted line into this plotting charts. But for now, is I hope is you can practice this two code to understand the logic of the range and the difference and the variance and the standard deviation, because they are the very important concept for statistics. And we will use that for later even these scatter charts. So thank you for your watching for this number 4 sub chapters. I hope you enjoy the current learning journey. If you like it, please follow my channel so that you can get a notification for the future uploaded videos. And I will see you in the next chapter to calculate the correlation between two data sets. Now is until the latest one is primarily we are working on one list of the numbers and not the multiple. So this correlation is another the ideas so that we can see those the numbers relationship. You may consider until now one list of the data. If we are talking like a line is the one dimension. When you have two data sets and talking about the correlation, it's like we expand one line to one the coordinate space to the two dimension. Now is two data sets represent two dimension, and their correlation is like this coordinate point x, y. Then we will find that, then that will the inputs for drawing the scatter charts. So see you next video. Bye for now.